Hello and welcome to QED's Data 5 from part S21. Now this question we just answered here about the fewer than half the population have the DTP3 vaccination, as hypotheses would come out like this. So the null hypothesis would be that, okay, in the whole population, the proportion of children who have had it is 0.5 exactly. The alternative would be that it's less than in the whole population. Now, these hypotheses are about population proportions. What proportional percentage of the answers are in this category as opposed to that category? And so far we haven't got a test that does that. And the test we need is what's called a test of population proportions. It's actually probably one of the most useful ones I haven't got in my lecture. So perhaps I should adapt the lecture to this. It's something that students often want to run. But it's easy to do in stata anyway. It's PR test, proportions test. And you're going to test that in the population, proportion of yeses here, because it's a specialised test that just looks for difference between noughts for no's and ones for yeses. So proportions of 1 is 0.5. So we can run that quite easily just by putting that code in. And here, I'm running that. So null hypothesis is the proportion of 0.5, and the alternative was that we think it was less than 0.5, fewer than half, and indeed you can't reject the null hypothesis. So as it seems that if it's true that in the whole population it's 50-50, the chance of getting the difference, the proportion as low as we did as 49%, remember up here, is that 49% having had the vaccine. The chance of getting that is lowish, but it's still 15% nearly, so you can't reject the null hypothesis. So there's not any strong evidence there that fewer than 50% of people have had the DTP3 vaccination. So we can't reject the null hypothesis. So I've lost the instructions, which is no good. There we are. So what can you conclude? No strong evidence that there is that fewer than 50% have had that. Now we can do the same thing for the other two. Is it true that this gives us evidence that the rates of measles immunization in the population is greater than 50%? Is that true? So H0 would be proportion of children in the population who have had measles is 50%. Proportion of the alternative is the proportion who've had measles is more than 50%. And then similarly for the other one, it would be instead of 50%, it would be 10%. Null hypothesis is that proportion of underweight children is 10%. Alternative would be that it's more than 10%. So to do both those, you can just add in the two obvious lines of code into the do file and execute those. So that's for the measles being 50%, that's for severe underweight being 10%. Have a look back and see how we interpret the results. So for the first one, if we assume that measles in the whole population is 50%, the chance of getting a difference as high as we did, above 50%, we got 56%, is indeed 0.000, so incredibly unlikely. So that's one of the strongest results we have got so far in these tests, that definitely at 1%, even at 0.1%, you can reject the null hypothesis. So this gives very strong evidence that the mean vaccination level in the population is greater than 50%. That's quite a strong result. This one here, again, if you assume that the population, here we're taking 10%, the proportion of underweight children is 10% in the population, the chance of getting a sample that we did, the sample of however many we've got, and finding, no, 8,000, yes, 8,000, that's fine. So the chance of getting a sample of 8,000 children and finding a mean as big as that, if the true mean is 0.1, is very, very unlikely, 0.1 less than 1 in 1,000. So we can certainly reject the null hypothesis very comfortably at the 1% significance level there. So in both cases, this evidence gives us quite strong support for the alternative hypothesis, that we conclude that both yes to the first one, more than 50% of children have had measles, and yes to the second one, not such a good one, unfortunately more than 10% of children are severely underweight. Okay, as it says, these are like single sample t-tests. In the next video, we'll go on to the more useful when you're comparing proportions between two different groups. But I'll save that for the next video. So thanks for watching.